Well, you welcome back. There is a question at IGCSE Chemistry 0620. Accord on what? Steel protection against what? Corrosion or rusting. Now, we have two: sacrificial protection and what? Cathodic what? Protection. Now, look at the question very closely. Without this information given, is this one sacrificial protection or cathodic protection? This definitely is not cathodic protection using an inert anode. Rather, it is what? Sacrificial protection, because there is no what? Power supply, battery, and the anode is what? Not what? Inert. So this definitely is what? Sacrificial what? Protection. So you have to sacrifice the anode to protect what? The cathode, which is made of what? Steel. But how will you know that this block of magnesium is the anode and this is the cathode? Now, if we look at inside this steel pipe, you have what? Iron. The mixture of iron and what? Carbon is an alloy. Steel is an alloy, right? Contains mainly iron and few percentage of what? Carbon. Now, the electron, if you look at to know which of them becomes the anode, which of them is the anode, but the other one is what? The cathode. How will you know which of them is the anode or cathode? I'll treat about what we call the metal reactivity series, the reactivity series of metals. Right, we have potassium, sodium, lithium, calcium, magnesium, the max. Then you have the aluminium, zinc. You have iron. You have tin. You have lead. You have hydrogen. You have copper. You have silver. You have gold. You have platinum. Now, if you look at iron, this is iron here, and this is magnesium, right? The element, the metals that are on top or higher up in the series are more reactive, right? Electron flow from the more reactive onto the less reactive. Magnesium is more reactive than iron. Iron in the steel, so electron will not flow from magnesium towards steel, and where electron flows from becomes the anode. So this is invariably the anode, and this the electron flows into is the cathode. So this is the cathode, right? So magnesium, electron lost by magnesium, right, is taken by iron. So magnesium undergo what we call oxidation. So the question, if you look at the question now, is that the block of magnesium connected, right? So electron will now flow from magnesium and goes into what? The steel pipe. And this is write an equation for that, just in case. This magnesium losing its valence electron is atomic number 12. So this is the valence electron, and this is electron lost, minus 2 electrons, and become what? Magnesium ion, right? Give an explanation in terms of electron transfer or electron flow why the steel does not what? Rust. Now, I can simply write that electrons move from magnesium to steel, right? No oxidation of iron in what? Steel. Right? No oxidation. Oxidation can only take place iron in the steel if electron flow from, let's say you connect here to here. This will not flow from electron is lost by the iron. It will be oxidized, because rusting is oxidation. Electron need to be lost by what? Iron, right? So this 5 electron is taken by iron, it will not be what? Oxidized. But if electron is lost by iron, it will be what? Oxidized. So no oxidation of iron in what? Steel. That's the answer. Now look at the next question. This is about cathodic protection because of the battery and the inert what? Anode. The inert what? Anode. And this is the cathode, right? This is the electrolyte, the seawater, and this is the power supply, right? You can also observe bubbles of hydrogen gas at the base of the water cathode, right? Now, the question, this is the electrolyte, right? Write an equation for the formation of the gas given off at the steel cathode during cathodic protection. An equation, right? for the formation of the gas, right? It's definite. I'm referring to what hydrogen gas. How do you present the formation of the hydrogen gas using an equation? Definitely, seawater has dissolved salts, and water as this is the formula for water, and inside water you have these ions, right? When the circuit is closed, right, you see electrons will now flow, and the ions will now migrate to the electrode of their opposite charge, right? Positive charge ion will go to the what? Cathode. And this will go to the what? Anode. Right? This is cation. Cations go to the cathode, C for C, right? Positive charge, you know the cathode is what? A negative charge what? Electrode. So when hydrogen ion or the cation gets to the cathode, what happens? Right? The hydrogen ion will now have to remove electron, right? This is hydrogen ion. These are the cathode. The discharge of hydrogen ion takes place at the cathode. So getting to the cathode, it will now accept or gain an electron and it becomes hydrogen atom. Hydrogen exists as a diatomic what? Molecule. So you need to be paired up. So you have this. So when you sum it up, 2 electron, and that is the gas, right? So that's basically the equation. Or you can write 2H plus. So either of this is what correct, right? So that's the gas, right? That's the equation, and it's balanced, right? Okay. Give one difference between the two what method. There are a lot of differences between what cathodic protection and what sacrificial what protection. If you look at this, these are differences between sacrificial protection and cathodic protection. Under sacrificial protection, the process is an electrical what cell, right? The setup is an electrical cell, while cathodic protection is electrolysis, not an electrical what cell, right? The second one is electron flow from the more reactive metal, which could be any of these, to iron. It could be magnesium to iron, aluminium to iron, or zinc to iron. Unlike this, electron flow from the battery. The process is powered by the battery, right? It does not need a power supply. That is under sacrificial well protection. It is a spontaneous well reaction. Right? First, you have 2 different metals deep in an electrolyte. Electron will move from the more reactive to the less water reactive. So that is invariably what a cell. It is a spontaneous reaction. It needs a power supply, a battery. This is non-spontaneous. It cannot start without what? The battery. It is powered by the battery. It uses up the anode, that is under sacrificial protection. Now, if you look at cathodic protection, the electrodes are not used up because the anode is what? Inert. The anode is what? Inert. So any of these could be what used. So you can write sacrificial protection. Uses up the anode, while in cathodic protection the electrodes are not used up. The anode is what? Inert. Right? The anode is what? Inert. Any of the differences I've given earlier, right? So this is a question based on a method of preventing what? Steel rusting or corrosion. I hope it's cleared. Find time to do more questions in this area to do you good. You can link up with me via this email or WhatsApp. Wish you guys the very best in your exams or classwork. Take care. Cheers.